Hey everybody, and welcome back to another Nielsen Networking video. This is part 2 of our 3-part series on DNS for ethical hackers and system administrators. If you missed part 1, I highly recommend you go back and check it out again via the link above. Now with that out of the way, let's begin. All right, and just like the first video in the series that you've already watched, right? We are going to use a program I wrote that will guide us along the process, make things a little more interactive, a little more aesthetically pleasing on the eyes. That said, the first thing we're being asked for here is a domain to explore its DNS records. So why don't we go ahead, I think in the first video we did YouTube. Why don't we do Google? We'll stick with Alphabet. We'll stick with Google like I just said. So let's go ahead and hit enter here. And then a quick reminder for those of you that aren't listening and following my advice, a quick recap of the DNS resolution process. In a nutshell, I'm not going to go into this because if you don't know what any of this means, you really need to go back and watch that video. But to summarize, video 1 was about the journey, the process, and video 2 is about the destination. All right, we will be starting with none other than the authoritative name server, the source of the truth. This is the target, ladies and gentlemen. Whether you're an ethical hacker, systems administrator, or other cybersecurity professional, this is the target that needs to be secure. Now, why is that? Well, let's start with what is an authoritative name server. The authoritative name server is a DNS server that holds the official, definitive, no question asked records for a specific domain. If you recall in the last video when we went through the process and you finally get to the authoritative name server and it asks, what is the IP for this domain? This server responds. Doesn't matter if that server's been compromised or if it's secure, whatever it is, it's going to return an IP address. Hopefully it's correct. There's no opinion, there's no caching, no delegation, just facts. Got it? Now you're probably wondering, why do the other servers honor this as a fact? Like why, when you get to this server, is this server seen as, the ultimate source of truth? Well, that's because of the DNS hierarchy itself and name server records. Let's take a step back. Let's say you have a domain you want to register, domain.com. You register your domain, let's do actually example.com because that could be a little confusing. You register example.com with a domain register, say GoDaddy, Network Solutions, whoever it is. Part of that registration process is they're going to ask you which name servers will be authoritative for example.com. Now you can choose to use, the registers built in like GoDaddy's or Network Solutions authoritative name servers, or you could choose your own. It's up to you. You get to decide what happens when anyone goes to example.com, what server they're going to be pointed to get the IP address. So the register then takes whatever you said, and it goes and stores them on the TLD name servers, top level domain name servers. So when a resolver comes along, let's say someone queried example.com, it's going to get to the TLD server and it's going to say, how do I get to example.com? TLD is going to say, ask this name server, and it's going to be whatever you specified as your authoritative name server. That's it. There's no questions. The resolver must ask them. It's not optional. It doesn't get to go rogue and say, well, I don't like those authoritative name servers. I'm going to go to these ones. It doesn't have a question. It must follow the chain like everyone else and end up at whatever was listed as your authoritative name servers. Again, those records could be altered and pointed to something that isn't what you originally set up if you had a weak password or something else, but without going down the rabbit hole, that's how the process works. Okay? It's enforced by the structure itself. There is no way around it. All right, now that you understand why the authoritative name server is the source of the truth, what actually lives on these servers and why are they known as the target and why must they be protected, secured, and hardened and tested for vulnerabilities by ethical hackers? Well, the number one reason is because of the zone data. The zone data could be DNS records in a modern database, such as DynamoDB, proprietary databases, or something else, but it could also be something as simple as a text file. You're running Linux and you have bind up, you're literally having your records stored in a zone file in plain text. There's also going to be configuration files on here that need to be secured. There's also going to be logs, and depending how busy this server is, there could be lots and lots and lots of gigabytes, terabytes, petabytes, lots of logs. And lastly, depending on the server, there could be DNS sec keys. These are cryptographic keys used in DNSSEC to digitally sign DNS data. They ensure I'll use security experts, authenticity and integrity. Lots of stuff there. But above all, the most important is going to be the zone data because it contains your DNS records. So what is this zone data or zone file, as I'm going to refer to it as? What is it? Well, I thought you'd never ask. A zone file is going to be a collection of all the DNS records for a domain that are going to be stored on an authoritative name server. Now, let's say google.com. It's going to have more than one authoritative name server, obviously, for redundancy and things like that. But they're all going to be stored on this authoritative name server. Then they'll be replicated between them, obviously. Now, they're going to be stored either in a traditional method, which is going to be in a text file, or they're going to be in a database. I'm not going to go over this because we kind of already did. Either way, the data is organized identically, which is going to be the name of the record, type of the record, time to live, TTL, or the data. I'll show you this in a second, what it actually looks like. And then this is kind of a redundant. I don't know why I added this to the video here, but we're going to skip it. And we're going to go straight to the actual example zone file. All right, and in this example zone file, you'll notice, like I mentioned in the previous section, you're going to have your name, your type, your TTL, time to live, and then the data. And when you have an @ sign, this gets confusing because you're like, we have @ signs here, 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 and down here. How can we have all the same name for different records? Well, the reason that is when you have an @ sign, that represents the whole domain. So @ will then take over the next record or the next field over, if you want to look at it that way. It looks at the type. So it's going to look at the name and the type and put those two together. So when you have the name and the type of SOA, it knows this is the start of authority for example.com. When you have an @ and a name server type, it knows these are the authoritative name servers for example.com. And when you have an @ and an A record, this is the main IP address. When someone types in example.com, it's going here. It's not going anywhere else. And as you go down, the record types will change. So now you're going to have, www, a record, which is going to point to this IP. Your API might be on a completely different server, and your admin portal might be over here. This might not even be an admin portal. It just might be admin.example.com for something else. I don't even know what it would be, but it could be something else. Now, the more confusing thing is when you get down here, you're going to have a mail A record and a mail MX record. Now, I know that's confusing, but I want you to think of it as like this. So when you type in, I know I need to send an email to example.com, it's going to pull up your MX record. Your MX record is kind of going to be like your address, right? So you now get the address. It's going to return your actual A record, which is going to be like the GPS to tell you how to get to your mail server. So this right here doesn't have an IP address, right? This isn't going to, how can you get to where you need to get to the server? So it's almost, I guess you could kind of think of it as a relay. It's saying, all right, how do I get to this mail server? So it's telling you, this is how you get to it. You go to this record, which points to the A record, which then will deliver you to the actual mail server. CNAME is going to be like an alias. So you could say blog is going to point to example.wordpress.com. Similar if you had like an alias and an email address, and then it's not letting me scroll down here. Here we go. And then a text record. These are going to be where you're going to put in like your SPF records or your like Google analytics verification records like that. Again, we're going to go all into this in detail in the next few sections, which we might as well get moving to right now. All right. And now that we know what's in a zone file and we kind of understand the point of it, how does it come to be? Like, how is it created? Well, let's take a step back and say, we have a domain we want to register, example.com. We register this with a register, GoDaddy, Namecheap, Network Solutions, whoever, there's a million of them. We've registered it. We then log into our DNS provider, which is most likely, well, I shouldn't say most likely, there's a good chance it's going to be the same people you registered your domain with. So you log in, let's just say GoDaddy for this example. We log in with GoDaddy to our example.com. We go to the domain, we click on example.com, we go to advanced settings, and we see DNS. We click on it and it warns us, do you really know what you're doing? And we say, sure, of course we do. So we sign in, we get to the zone file, and we see, there's some name server records that are probably pointing to something like secureserver.net, GoDaddy's name servers. We may have an A record that's just pointing to one of GoDaddy's landing pages for free publicity for them if someone goes to your domain. And may or may not have a few other records. Most likely not. But let's say now we want to add our blog, we want to add our website, we want to add our mail server, we want to add some text records for Salesforce or whatever it is. We want to add all that. We go in, we do all that stuff, we add all that. We close the zone file, whatever the TTL is, it replicates out and everything's good. We're happy. We secure our GoDaddy account with, multi-factor authentication and any other security options they give us, right? Because we want that to be secure. We don't want to be that person that didn't secure their GoDaddy account and have someone else go in, and now our example.com is pointing to some other nefarious website. We don't want that. So that's the zone file in action. We've now created it. It's live. And just a reminder, these are all stored, and apparently I thought this was important because I've mentioned it like 20 times now, in a text file or database, right? Skipping that. Let's say now someone goes to example.com. It's now gonna, the DNS is now gonna query, go through the whole process. It's gonna get to that zone file, and it's gonna say, oh, you wanna go to example.com, here's the I record, here's the IP, returns it. It's gonna now get you to that website. DNS records are zone data. So when I said, that zone file, zone data, they're one and the same. It's a collection of DNS records. Each entry in the zone data is one DNS record. So you're going to have one A record, one or two MX. You could have multiple A records, don't get me wrong, but they're all going to be individual. Storage method doesn't matter. The data is always stored the same way. I had to just mention that one more time. All right, now that we're clear on the storage, let's talk about the record types. An A record. An A record maps a host name to an IPv4 address, not to be confused with an IPv6 address, which we'll talk about in a minute here. So an A record, let's think about it like this. An A record, they're the translation layer, say that. Think of google.com. Humans use google.com. But the internet uses an IP address. So an A record translates what humans need into what computer needs. In other words, into a domain name into an IP address. Pretty straightforward. Hopefully that example makes sense to you. Remember, the @ means the root for the domain. So example.com itself. All right, and following along with an A record, we have an AAAA record, or a quad A record, which is what everyone calls them. These are IPv6 A records. They're the same thing as an A record, meaning you're going to point your name to an IP address. The difference is this is going to be IPv6 because the internet is actually running out of IPv4 IP addresses. So this is the solution to that. Okay, then we have C records. These are going to be your aliases. Instead of creating like a duplicate record, you can create an alias to point to your subdomain to someone else's service. But you can't use a CNAME on the root domain, if that makes any sense to you, as I said right here. So you could have, blog going to actual example.wordpress.com, but you could actually have blog going to a completely different website. All right, MX records, mail exchange records. MX records route email to mail servers with priority levels. That's way too simplistic, so let me give you a little bit of a background. So think of it like this. An MX record tells the internet where to send email for your domain. So example.com, send my email to whatever these records say. Think of it like this. You tell the postal service, if you get any deliveries for me, send them to this address. That's what this is doing. Now, the priority levels are just like they sound. They go lowest first. Lower priority servers will get tried before the other ones. This also gives you redundancy, and it allows you to remember each one of these records has to have a corresponding A record that points to an IP address. And these IP addresses can be different servers, and geographically, you could spread them all over the globe. That way, let's say for some reason, the area in priority 10 goes down, it would time out and then it would roll over to the next one. Got it? And you can also you could actually point, let's say you registered example.com, but you didn't want to host it on GoDaddy. You didn't want them to be in charge. You wanted Office 365 or you wanted Gmail. You could register the domain and point it to their email services. It doesn't have to be your own. It's flexible as long as you point it to the MX record. And as far as ethical hacking goes, if you can compromise an MX record, imagine what you can do. You can redirect all that email to your server. So that's why email is so important during the reconnaissance phase, MX records, I should say, not just email, during pen testing. So hope that makes sense. Let's move on to the next record type. All right, name server records. These records point to the authoritative name server for this domain. Simple, right? But wait, why do we have NS records on our own servers? Well, the reason is because of redundancy, zone transfer, completeness, and delegation confirmation. And let me show you what that means, because I know right there, looking at that probably doesn't mean very much to you. So redundancy, backup server. So we have NS1, 2, 3, right? Those are redundant name servers. If one goes down, we can then query, or the DNS hierarchy will query 2 or 3, right? It will list all of them so everyone knows our authoritative name servers. Zone transfers. The zone transfers are replication, if you will. So you're going to have the master copy, which is going to be NS1, and then you'll have NS2, 3, 5, whatever you have. And every so often, the other name servers are going to ask one, do you have any new information for us? And one may say yes or no, and it will sync with it. It's not like 2 syncs to 3 and 2, or 2 syncs to 1 and 3 to 2. Everyone goes to 1. 1 is the master. It's kind of like master slave in replication. It's the same principle there. And then completeness. This means it's self-documenting. The zone file should contain all the records. So if anyone requests it, you're going to get all the records. You're going to get all the MX text and all that. But most importantly, you're going to get the name server records proving you own that domain and that you are authoritative. And the last thing is the proof of authority. So as the resolver is going through, remember, it's going to go recursive resolver, root name servers, TLD, authoritative name server. When it reaches your authoritative name server, meaning whatever you assigned when you registered your domain, it responds with its own name server record. And that confirms you are the authoritative name server for this zone. You're the badass. This is proof of the authority in the DNS chain. So hopefully that makes sense. You might need to rewind that section, but that's how it functions. All right, SOA record, the start of authority record. There is only one SOA record for an entire zone. So it's not like an A record or a text record or other records where you have multiple records of that type. There is just one for the entire zone. And the start of authority record contains the administrative metadata for an entire zone. So what does that mean? Let's take a look. Here's an example of what an SOA record might look like. So let's take a look at all of this step by step here. So let's start here with the ns.example.com. This would be the primary name server for the entire zone. This is the master, all other name servers listed. Verify with this one for the correct data. If they have something incorrect or whatever, they will be synchronized with this primary, and whatever the primary says goes for the entire zone. That is then followed right here by the responsible email. Think webmaster email admin contact for a domain. When you look up a domain, if it's not behind, even if it is behind a proxy DNS service, they'll always have an admin contact for a domain, right? Now this might be confusing because it says hostmaster.example.com. You're like, that's not an email, that's a subdomain. Well, you're right and you're wrong. When it's written this way in an SOA record, it's interpreted as hostmaster@example.com. They can't use the @ symbol here because the @ symbol in a DNS zone file is reserved, you remember, for the root of the domain. Got it? Moving on down here, we have serial, refresh, and retry. The serial is going to be the version number for the domain. Think if you have an application and you have the first version, second version, third version, so forth, right? Every change will be an incremental change in the serial number. Why this is important? This is important because the secondary, and every other name server in the zone have to know when the master zone file has been changed. That way it knows when to synchronize. I guess it could technically just every so often synchronize either way, but the zone file helps by saying, let's not overload this if it's unnecessary. So if there hasn't been a change to the serial number, it doesn't synchronize. Now, the refresh here, this is how often the secondaries check that primary for updates to that serial number. Remember how I said we don't want to inundate it with too many let's resync. This kind of tells it every hour, let's check now. Now the retry is a little different. This is if it can't reach the primary. This is how often it's going to retry to reach the primary, and this is exactly set so you don't over inundate the primary with requests. Hey, are you there? Are you there? Because technically you could almost DDoS your own main authoritative name server if you're checking every so often constantly for updates, right? You wouldn't want to do that. And then let's look at the other two. The expiration, this is kind of important, but it's also very confusing. The expiration tells people that are querying your domain after this long, everything's going to be obsolete. So it's not, I guess, let me say that again. So this tells your domains, your secondary and every other name server, if it can't reach the primary in this amount of time, stop serving data. So let's say day one, the primary server crashes. The secondary still has the old data cache. It's happy. It still serves. It will go down third day, fourth day, fifth day. But when it gets to day 7, it's going to say, you know what, I can't get to that master. It is the start of authority. I can't reach it anymore. I am not going to give out data. Someone goes to that site, queries that, it's just going to get a page ID displayed or other error. It's not going to give that data out. Now you're saying, why? Why wouldn't it just stay up? Well, the reason it doesn't do that is because it's better to give out nothing than to give out wrong data. What if you were to give out a record and let's say that IP address for that old server has changed. Someone else has now replaced it with an adult website or a nefarious phishing website or something else. It's better for your domain not to give out bad information than give out no information at all. That's the thinking behind it. Understand? And the TTL here, this is the default TTL for the zone. So if you don't enter a TTL when you're entering an A record or MX record, this is going to be the default. That's going to be it's going to be filled in for you because you forgot to put a TTL. Now, if you do have one, it will override this. So if you have one that says 3600, it's not going to say, well, the zone says this. Whatever you have for an individual record will overwrite this. So why is the SOA important? Why does it matter? The main reason it matters is it's how it controls how secondary servers stay in sync with the primary authoritative name server. Remember, primary has the master, secondary servers periodically check anything new. They check the serial number. If changed, they download. If not, they don't. If they can't reach it, they eventually stop answering queries. That's why it's important. And it's important for ethical hacking for a lot of those reasons, but we're going to review all those reasons why it's important for ethical hacking at the end of this video. And we'll go into it in depth in the third video. All right, and the last record we're going to go over is known as the CAA record, Certificate Authority Authorization Records. Now, what are these? Certificate Authority Authorization Records state in your zone file who can issue SSL certificates for your domain. Without these records in your zone file, anyone technically could attempt to request a certificate on your behalf, and the certificate authority they're requesting from would have no way to verify if it's okay and if they're allowed to do that for you. So it's very important that you list what certificate authorities are allowed to issue SSL certificates for your domain in your zone file using these records. Without it, it is a giant hole that anyone technically, remember, could go and issue SSL certificates for your domain. Hope that makes sense. If it doesn't, think of it this way. If you're a bouncer at a club, you go up, the person's trying to get in the club. They say, oh, you're not on. We're not going to let you in the club. That's what this is. It's kind of like a whitelist for certificate authorities that are allowed to issue certificates for that domain. All right, and as we're closing out the video, I thought it would make sense to kind of go over an example of a zone file again. Now that you've learned each individual record type, let's look at the zone file again so you can kind of just reinforce that information. But while we're going through it as an added bonus, I'll give you a little bit of information what you ethical hackers or system administrators are going to be looking for. On the ethical hacker side, what you would be looking for, and on the system administrator side, what the ethical hackers are going to be looking for to give you some information on how to protect yourself, right? Because they're not just all going to be ethical hackers out there. So let's start up here at the top, the SOA record. These are going to be the records or the record that contains your zone metadata. Most importantly, it's going to contain the information on your authoritative name server, which is the primary, how often it syncs and things like that. Now, as an ethical hacker, you're looking to see how often does the serial number change on this record. In this record, is it changing often, meaning the zone's being updated often, meaning it's actively managed, or does it stay the same? Is it stale? No one's managing it. Chances are, if you do happen to get into compromise this record, they may not notice for who knows how long, if ever, right? Unfortunately, it could also mean that it's abandoned and it's going to go offline at some point. Who knows? But that's what you're looking for. So as an administrator, you're looking to say, well, I better, get in there and at least maintain this record to make sure there's not stale records or anything just to get in there that show that you're actually maintaining that record. Now moving down to the A records, these are going to be, well, actually, I should say the name server records. These are going to be the records that say this is our primary authoritative name server and this is a secondary authoritative name server. What you're looking for are there multiple ones. That is a blessing and a curse, because if it's only one, you only have one target. If you have multiple, you have multiple targets, right? And the secondary name servers, I hate to say it, are more often less monitored. So that's what you're going to be looking for as an ethical hacker. And as a system administrator, of course, obviously, you're going to want to make sure you maintain both of those records, right? All right, now we have the A records. The A records and quad A, which I didn't list, but they're pretty much the same thing here. The only difference is A records are pointing to IPv4 IP addresses, quad records, or AAAA records, if you want to call them that, you'll be the only one, are pointing to IPv6 IP addresses. So when someone goes to www.example.com, they go here. You know what? As a reminder, if they just go to example.com without www, they're going to go to this IP address. And technically, this could be different than this. I don't know why you would do that, but I don't judge. It could be. So what are we looking for as ethical hackers or system administrators? As ethical hackers, we are looking for, well, let's look for the number of records. Are there 3 records in here? Are there 300 records in here? 300 records give us, as a system administrator, a bigger headache to maintain, right? We want to make sure there's no stale records out there. We want to make sure we don't accidentally leak internal records while we're putting all our other correct records out there. As an ethical hacker, 300 records gives us a much bigger attack surface than 3, right? You're also looking for, are there duplicate A records? So is there admin again, or to the same records, or the same A record, but pointing to different IP addresses? That would indicate something like a load balancer, which again, more attack surface, right? So that's what you're looking for in A records. Now let's look at mail server records. All right, mail server records, why are they important? Well, let's say we receive an email from Gmail. It's going to pull up, for example.com, our MX record. Our MX record is going to say, imagine we had multiple. It's going to take the highest priority. So 10 was the highest priority. It's going to say, oh, you want to send an email? You need to go to mail.example.com, which is an A record, just like up here. But this A record is actually pointing to our email server. Now, this email server could be our own email server that we have out there. It could be Gmail, it could be Office 365, etc. Right? So that's the flow of how that works. Now, why is this important, and what does this information tell us from ethical hacking or system administrator? Well, first of all, it reveals the entire email infrastructure, right? That's important. Shows which services, like I said, handle it. Is it Gmail? Is it Office? It looks up, are there multiple MX records? Are the MX records different priorities? Are there low priority MX records that are outdated possibly? Maybe they're an easier target. But it also, if there's multiple MX records, that's more attack surfaces, right? So that's where you would, and again, we'll go into this in more detail in the next video, but this is where those MX records come into play and why they're important. If you don't have multiple MX server records out there, maybe you should get a secondary one. And maybe for redundancy, maybe you need to get rid of that stale. Maybe you're not using Gmail anymore, or maybe you're using Office 365. Maybe you need to change that information. So from a system administrator side, that's where you'd want to keep this information clean. And you'd want to make sure you don't have any internal subnets or subdomains listed under your mail servers. And of course, we have our CNAME, our aliases, our alias records, if you will. So we have blog.example.com is actually going to go to example.wordpress.com. Now you're thinking, well, that's not that big of a deal. Well, it is a big deal, because this tells you, well, we're actually now outsourcing some of our services to these other companies, but we're kind of passing them along as they're our own. So not only does that give us more attack surface, that also, from a system administrator side, we need to make sure we're doing pen testing on them. We need to make sure we're vetting their security. Are they running the proper security to protect our information on their services, right? We need to verify that vendor. So that's kind of how that comes into play. And there's a lot more to it. You'd obviously want to make sure you don't point to a website that they're offline, because that's going to make you look pretty bad too. But more to that on the next video as well. All right, email authentication or text records. These records are critical. It is critical that you have a correctly configured SPF, DKIM, and DMARC record, unless you want to have your domain spoofed all over the world and receive more spam. It is also critical that you do not leave stale verification text records out there. Meaning, let's say you're signing up with web.com for a domain, right? Or hosting, I should say. You need to verify you own it, you leave it out there. But what's going to happen is now you're going to have that information that may have a reference to web.com in it, and people are going to know, well, their technology must use web.com because this is a verification record for it, or Google Analytics or things like that. And again, more attack surface. So that's where these text records or email authentication records come into play. Okay, and I don't see a CAA, a certificate authority authorization record in this zone file. So just a quick refresher on what that is. That tells the certificate authorities who's allowed to request certificates on the domain's behalf. When you don't have one of these, anyone can issue it. And believe it or not, most organizations forget this record entirely, which would be considered in a pen test a critical vulnerability. Now, what could happen? A quick example, let's say we're doing a pen test, we find out this record's not there, we go and we request a certificate, we get a certificate, we perform a man in the middle, users see this process, they don't notice anything because their certificate in their little bar shows a lock and it's green, they're happy, and they're none the wiser and they're passing us all their information. So that's how that could be used, and that's why it's critical that you actually put this record in your zone file. All right, and as we near the end of the video, let's just take a moment and review one more time the key takeaways that I hope you take with you after this video. I need you to remember, DNS records are database entries in zone files or zone databases. Each record has a name, a type, a time to live, and data. Common types of records are going to be your A records, your quad A records, your CNAME records, your MX records, your text records, your name server records, startup authority records, and your certificate authority authorization records. Records are all hosted on authoritative name servers, with the main or the master authoritative name server being listed in the startup authority record. TTL, time to live, controls how long the records are cached. These records are queryable by anyone, meaning this is public information. You can go out to MX Toolbox or any other site and query these records. Misconfiguration of these records equals security vulnerabilities or downtime or mass outages. Ask AWS or even ask Microsoft Azure. It happens. Quick record type reference. A records are going to be your IPv4 addresses. Quad A are going to be your IPv6 addresses. CNAME are going to be your hostname aliases. MX records are going to be your mail server records. Text records are going to be your text data, SPF, DKIM, DMARC, domain verifications, things like that. NS are going to be your name server. Startup authority records are going to be your zone metadata. And certificate authority authorization records are going to authorize what certificate authorities can be used for your domain. So you want to query google.com, which we entered at the very beginning of this to kind of see what it looks like. Let's see what we get when we query it with dig. Sure, let's go ahead and let's query it and see what we get. We're going to go up here and we get our A records. Remember, when we get our A records, we would be looking to see are any of these internal IP addresses, are any of these orphaned records. And then we're going down here and we're looking at the IPv6 records. And we're saying, I wonder if any of these targets are weaker. Maybe they're not as well protected as IPv6 or IPv4 because IPv4 is used more often. Something to think about, right? And then we have our MX records. Are there any records in here that let us know how many records are there? Unfortunately, we're only getting one returned here, probably in the query I did. But are there multiple records? Does that give us a bigger attack surface? Down here, we have Google's text records. They have, again, their domain verification. They have their SPF record here, right? And then they have another one. And then down here, they actually have their name servers and they have their priorities 1, 2, 3, and 4, right? What you'd be looking for there, are there multiple? Yes. Are the secondaries less protected? I don't know. They actually don't, we're not getting their startup authority. We're not getting their CAA records. So we're missing a few records. It's going to be most likely the way I pulled it. We're not even getting CNAME records. So, all right, let's just manually pull it up. So let's do a dig CNAME google.com. All right, and right here we are seeing that CNAME, here it is. The Google does not have any aliases. So Google is Google. Google's Google. Go figure. And then down here, it actually showed the SOA record. Like I didn't have to pull it. I thought I'd have to do this. But it pulls it anyway. So anyway, the SOA is actually showing us right here is the authoritative name server like we learned. This is going to be DNS admin at, remember we replaced the period with an at, google.com for the administrative contact. Then we have our serial number right here. We have a refresh, retry, expire, and time to live. And let's look up the other one. What was it? CAA, Certificate Authority Authorization. Okay, and this is actually an internal certificate authority for Google. They're saying no one else other than Google themselves can issue certificates. So they're pretty much the ultimate authority for their domain. When you're Google, I guess you can pull that off. Let's see if we can find one for another domain that has, let's look at Ford.com. And it looks like they're using their own as well. Why don't we look up everyone's favorite website, right? Slashdot.org. Great Linux website. You go here and okay, they actually do list who can issue certificates for them. So here you can see it in action. Pretty cool, right? All right, and on that, let's just clear this up here. I know some of you are insistent that I do a Command L. So I can't even do it. See, it's not working for me here. There you go. See, that's why I don't do it. It's just a pain in the ass. All right, now that I am thoroughly irritated and frustrated by you Control L people out there, I'm going to end the video. I hope you enjoyed the video though, and I hope you are looking forward to the next video where we're going to actually get in and see how we can utilize what we learned in video 1 and video 2 for ethical hacking, system administrator, or just anyone who needs to secure DNS or learn how to use DNS the proper way, what to look for, what to guard against, and all that fun stuff. So I hope you've enjoyed the video. If you did, I would appreciate a like, subscribe, ring the bell. If you're really generous, we do have memberships here. There's not much in there yet, but there will be over time. Anything is appreciated. So on that note, I will talk to you in the next video. Have a great day.